Hello and welcome to the final part of Chapter 1, 1.5, Explosions. Not as exciting as it sounds, unfortunately. The way I like to think of it is that we start with two objects at rest, 0, ending up as two objects flying apart with, obviously, velocities and masses. Now, to write this in a formula, we have 0, the momentum is equal to 0 because the velocity is 0, will equal the momentum of A, so mass of A times velocity of A, plus the mass of B multiplied by the velocity of B. Now, this doesn't look like it should work, because it doesn't look like momentum is conserved, but to make this work, we move the momentum over to the other side of the calculation. Now, although this doesn't look like it works if we look at this, if we ignore this for now, and just look at the calculation, moving this, we would have to take away MAVA, so we would have minus MAVA equaling MBVB. Now this is the formula we have to work with, and in this case the minus sign indicates direction. So with that in mind, let's move on to the questions. So, question 1. A shell of mass 2 kilograms is fired at a speed of 140 meters per second from an artillery gun of mass 800. Calculate the recoil velocity of this gun. So, this will be after everything takes place. We don't need to think about what happens before the collision because we know it's equal to 0. So what we want to do is find the momentum of the bullet. This will be the bullet, this will be the gun. So we know MV 2 multiplied by 140 will equal minus 800V. So this is the bullet going that way, this is the gun going that way, and we know that because of the minus sign. Now, this is equal to 280, and that's going to equal minus 800V. If we move this down, we end up with this. So V is equal to minus 0.35 meters per second. Obviously, this will be in the opposite direction to the bullet. Okay. Move on to question 2. In this question, there is a laboratory experiment to measure the mass of an object X. Two identical trolleys, A and B, each of mass 0.5 kilograms, were initially stationary. Object X was fixed to trolley A. So let's imagine a nice big object X attached to trolley A. When a trigger was pressed, the two trolleys flung apart. The two trolleys moved apart in opposite directions at speeds of 0.3 they moved apart at 0.3 and 0.25. Now, the first part asks us, which of the two speeds given was the speed of trolley A? Now, in our formulas, mass times velocity equals momentum, we would imagine that if the mass increased, the velocity would have to decrease for momentum to be conserved. So, if we know that trolley A has object X attached, that increases m, so v would have to be lower. So we know that the velocity of A would have to be the lower value, 0.25. Now, part B asks us to show that the mass of X must have been 0.1 kilogram. So, to calculate this, all we need to do is take the mass of B, which we know to be 0.5, 0.5 multiplied by the speed, which we know must be 0.3, will be equal to the negative 0.25 times by A plus X. We know A is 0.5, but it's easier to leave these in brackets for now. So we get 0.5 times 0.3 is going to be 0.15, and we're going to want to take this over here. So we divide that by 0.25. And we find that 0.6 is equal to A plus X. And we know that A is 0.5. So it's nice and easy. Sorry. Bit of sign error. Now, we want to take this 0.5 away from here. So we get that 0.1 is equal to X, proving that X is 0.1. Question 3. Two trolleys of mass 1.2 and 0.8 initially at rest. When a trigger is pressed, on one of the trolleys a spring pushes the two trolleys apart. Trolley Y moves away at a velocity of 0.15 meters per second. So, this being trolley Y, this being trolley X. So this trolley is moving away with a velocity of 0.15, and this is going to be part I. What is V? Now, using our equation again, we know that 1.2V will be equal to negative 0.15 times 0.8. The sign isn't particularly important, but it's nice to have just to, in case you're asked which direction it's travelling. So minus 0.15 times 0.8 is equal to minus 0.12. So to get V on its own, we divide by 1.2, and we find that V is equal to 0.1 in the opposite direction of this. Nice and easy. Now part I asks us to calculate the total kinetic energy of the two trolleys immediately after the explosion. Well, this is fairly simple. All we need to do is apply our half mv squared, and we now know that that is the velocity of x. So half of 1.2, 0.6, multiplied by 0.1 squared. We don't need to worry too much about the minus sign, because if you square a minus number it becomes positive. We have this, and we're going to add it to this. So half 0.8, 0.4 multiplied by 0.15 squared. This should give us our total kinetic energy after the explosion. Quickly do that on a calculator. So we're going to get 6.6 times 10 to the minus 3 plus 9 times 10 to the minus 3. So this will give us a total of 0.015 joules. This is our total kinetic energy after the explosion. Now, in part B, it says, in part A, if the test had been carried out with trolley X held firmly, calculate the speed at which Y would have recoiled, assuming the energy stored in the spring before release is equal to the total kinetic energy calculated in part AII. Now, this is our kinetic energy, which makes this a little bit easier. So what we're trying to find is the speed of Y if V didn't move at all. Now, if we draw this again, this is X, this is Y. If this didn't move at all, it would have a kinetic energy of 0, which would mean this, Y, would get all of the energy. So, we're looking for V. If we use half, mass, we know is 0.8, times V squared, and we know that it gets all the kinetic energy. So this will be equal to 0.015. Now, to simplify, we can get rid of the half, 0.4 times V squared, and then divide. So we get V squared is equal to 0.015 divided by 0.4, and this will allow us to find V. If we square root this, if we square root that, we get V. Nice and sweet. 0.4, and that gives us an answer of 0.19 meters per second. That's what Y would have if it got all of the energy. Final question, question 4. Question 4. A person in a stationary boat of mass 150 kilograms throws a rock of mass 2 kilograms out of the boat. As a result, the boat recoils at a speed of 0.12 meters per second. Calculate in A the speed at which the rock was thrown. So we need to find V. 0.12 multiplied by 150 will equal minus 2V. 0.12 times 150 is equal to 18, divided by minus 2 will give us 9. Minus 9 goes in the opposite direction of the boat. Now, part B says, find the kinetic energy gained by, in I, the boat. Now the kinetic energy of the boat will have gone from 0 to half 150 times 0.12 squared. It's just adding numbers into the formula. So that's going to be 75 multiplied by 0.12 squared, which gives us 1.08 joules. That is the energy of the boat, or the gain in energy. It's gone from 0 to this. In part I, it asks us to find the gain in kinetic energy for the rock. Again, half the mass multiplied by V, which we calculated here, to be 9 squared. So that's 1 times 9 squared. which is 81. Nice number. Easy peasy. I really hope this has helped. Anyone get their heads around explosions? Please like, subscribe. Have a good evening or morning or day. Goodbye.